Hello everyone, we want to look at how to convert a galvanometer into an ammeter. And the first thing we need to know is what is an ammeter and what is a galvanometer. An ammeter is a device, an electric device that is used to measure or detect current in an electric circuit, whereas a galvanometer is a device used for measuring and detecting a very small amount of current. Note, ammeter is used for detecting and measuring current, while galvanometer is used to what? To measure a very small what current. My name is Tutokoko, and in this tutorial, I want to explain to you the concepts of galvanometer and ammeter. How do we convert galvanometer into an ammeter? Now, in order for us to convert a galvanometer into an ammeter, we need a low resistance wire. Somebody say low resistance wire. Yes, we need a what? Low resistance wire. And the name of that low resistance wire is called shunt. Please take note of this. If you are writing JAMB in 2026, you come across questions on shunt and multiplier. What is a shunt? A shunt is a low resistance wire that is normally connected in parallel with the galvanometer in an electric circuit. So, for us to convert galvanometer to ammeter, we need what we call shunt. Now, let me draw the circuit diagram, then we proceed with the explanation. All right, so we have our direction of current flowing in this direction, then connected to our galvanometer. So this is our what? Galvanometer, right? So we move on. So here we are going to connect. This is a terminal here, end points here. We connect a shunt in parallel. So you must know the parallel connection and what? Series connection. Of course, in an electric circuit, two or more resistors can either be connected in two ways. Either you connect in parallel or you connect them in what? Series. So we have two types of connections. We have the parallel connection and the series connection. As a student, you should know when two or more resistors are connected in parallel and when they are connected in series. But if you are watching me for the first time, like this page, share this page, and comment and tell me your observation in this video. Let me really explain how we connect two or more resistors in what? In parallel. When we connect two or more resistors in parallel, of course, this is symbol for what? Resistor. When we connected two or more resistors in parallel, we connect them end to end. This is what we call a what? A what? A parallel connection. This connection here is a what? Parallel connection. This is resistor 1 and this is what? Resistor 2. Okay, what about a what? A series connection. A series connection is drawn like this. This is a what? Series connection. When we connect them side by side. So this is R1 and here is what? R2. But in the case of this, in the course of this study, we are not going to connect the shunts to the galvanometer in series. Rather, we'll connect them in what? In parallel. And that's why this is our galvanometer. This is our what? Galvanometer. And here is our what? Shunt. And here's our what? Shunt. And don't forget, a shunt is a low resistance wire that we connect in parallel with the galvanometer in order to convert the galvanometer into what? Ammeter. Right, without wasting time, let's move on. Now, the current flowing here is the effective current in the circuit. Now, at this point here, part of this current is splitted, and part of the current here flows through the galvanometer. We call it current across the galvanometer. This is the current that is flowing through the galvanometer. And of course, the remaining part of the current flows through the what? Shunt. So this direction here is showing that current is flowing here towards the shunt. So we call it IS, current across the shunt. And this is current across the galvanometer. And this is the effective current in the cycle. Of course, this is a resistance. So we call this resistance of the galvanometer. And this is a shunt. And a shunt is a resistance wire, but with low resistance wire. So we call this resistance of the shunt. So these are the parameters you need when you want to convert galvanometer into an ammeter. Am I making sense? All right, now let's proceed. So Now, don't forget, when two or more resistors are connected in parallel, take note of this information. The same potential difference, the same what? PD, the same potential difference flows across the resistors, but they have different current. They have what? Different current. And that is why you will see that I have IG and I also have what? IS. So IG is the current flowing through the galvanometer, and it is very different from the current that is flowing through the what? Shunt. Take note of it. So from here, I know that I is equal to what? IG plus IS. We want to convert this galvanometer to ammeter, so I need a shunt. So this shunt is what I want to calculate. Take note. From here, what is the value of the current across the shunt? Of course, making IS subject of the formula. IS will become what? I minus IG. So I minus IG will give us the current flowing through the what? Shunt. So if the current here is 5 ampere and 2 amperes flows through the galvanometer, how many ampere will flow through the shunt? That is 5 minus 2. That will give us what? 3. So that's how we get the formula for current on the shunt. Now, from what I said the same potential difference. So this means that the potential difference across the galvanometer is equal to the potential difference across the shunt. Why? Because they are connected in parallel. Take note of it. When two more resistors are connected in parallel, the same potential difference flows across them, but different currents. Of course, from Ohm's law. Do you know Ohm's law? Yes. If you are a physics student and you don't know Ohm's law, please go back and study Ohm's law very well. Because when you talk about electricity and its cycles, you must know Ohm's law. Very important. So what is Ohm's law? State Ohm's law in the comment section. Now let's go back to the class. Ohm's law states that what? The current that is flowing through a metallic conductor, e.g. a wire, the current flowing through it is directly proportional to the potential difference connected across its end, provided that the temperature and other physical quantities are kept constant. So mathematically, V is proportional to I. So this means I'm going to introduce my constant, right? That is equal to IR, where R is what? Proportionality constant, which is our resistance. So now from here, I will now replace this potential difference with what? IR. So instead of going to write V, I'll change it to what? IR. Do you know what I want to do? I want to develop a formula for calculating the shunt, that low resistance wire. So this becomes IR bracket what? G. And this becomes what? IR bracket what? S. Right. So let's move on. Not wasting time. So remove the bracket. We have what? IG RG is equals to IS R what? S. But I said IS is what? I minus IG. So it becomes IG RG is equals to into bracket I minus IG RS. What are we looking for? RS. So we are almost done. Right? So therefore, the formula for our shunt is equals to IG RG divided by what? I minus IG. So in case you come across a question that's talking about conversion of galvanometer to ammeter, just know that you are required to calculate the what? The shunt in the circuit. And to calculate the shunt, I just show you how I derive it, how we derive the formula rather. And this formula RS is equal to IG RG divided by I minus RG. So this is part 1 of conversion of galvanometer to ammeter. I've been able to develop and explain all the concepts you need to know, and as well the formula for calculating shunt. If you want to watch the second video and you want me to do the second video, drop in the comment section and check my next post. You see the part 2 of this video in my next post. Thank you. My name is Tokoko. Do well to share this page, share this video, invite your friends to like this page so that whenever I drop educative content, you can get the notification, right? Thank you. Bye.